While you're doing that, I will go ahead and introduce you. So next up is Tu. She earned her PhD at the University of Tasmania in Australia in 2016. She is now a first-year postdoctoral researcher at the Aquatic Animal Health Laboratory at UC Davis and is involved with different projects investigating the pathogenesis of emerging bacterial diseases in cultured fish, specifically Streptococcus in white sturgeon and Edwardsieliosis in salmonids. So it looks like your screen's ready to go. Take it away, Tu.
Thank you, Nick. Hello, everybody. Today I would like to present our finding for co-infection of Mycobacterium salmonifilum and Mycobacterium calonae in China salmon. And first, I would like to read the introduction about Chinese salmon. As we know, Chinese salmon are a keystone fish species in the Pacific Northwest. Yeah, they are vital food source for diverse wildlife. As you see, the photo, the bear eat the salmon, and the bottom photo, the seal eat the salmon, and also we have a lot of other photo that's wildlife need the salmon. So the salmon is a very important food source for the diverse wildlife. China salmon is anaerobous fish. That means they spend their older supply in the salt water or in the ocean around 1 or 2 years, and they move a long way to the river to lay eggs there, and the fry hatch in the stream, and they live in the river around 1 or until 2 years, and then they move back to the ocean. Some population of China salmon are federally listed as endangered or threatened. About Mycobacterium, we know Mycobacterium aerobic, facultative intracellular, non-spore forming rod, gram positive, and acid fast. It's a zoonosis disease can happen in the human. As you see the photo, it's a swimming pool granuloma or fish handler disease in human, and you can see that the hand have infected with the Mycobacterium. The classification of Mycobacterium, we have over 199 species described today. There's Xerophytes, opportunities, and opiate pathogen. They can divide into the slow row or the rapid row. The low rows root may be difficult or impossible to cultivate. They can reduce pigment. They need the optimal temperature for row, and Mycobacterium can reduce the disease as tuberculosis or non-tuberculosis, focal or disseminate. And the overall relationship among the major group of Mycobacterium species, recent paper of group HO in 2018, they divide Mycobacterium into 5 monophyletic groups. And you see in the top of 2 groups, we have Mycobacterium belong to the fast growth, and the bottom 3 group belong to the slow grower Mycobacterium. The first group is Mycobacterioides. Genera Nora is Abscessus, Calonae class. It have Mycobacterium calonae and Mycobacterium somnifilum there. The second place is Phototum vaccae. Third one is Mycolizibacteria genera of Nora, Mycobactericillibacillus, and the main xenon of Mycobacterium tuberculosis simile is mostly include Mycobacterium species infected to the human. In fish, we can see 3 Mycobacterium like Mycobacterium marinum, fortunatum, and Pelonia are the most common etiological agent of atypical mycobacteriosis. And we can see other species of Mycobacterium like Mycobacterium somnifilum and Mycobacterium sauci have reported in the white fish in the US. And you can see the photo of the round fish. It has a Mycobacterium infection with Mycobacterium marinum, and you can see inside their body have a lot of white noodle, and it's called by Mycobacterium. Thus, the infected fish may reach 50% mortality without clinical signs due to the chronic nature of the infection. In this presentation, we aim to describe the unusual case of mycobacterial co-infection in cultural China salmon fingerling in Davis, California, include phenotyping and molecular characterization of bacterial isolates recovered from the disease, and also histopathological analysis of the infected fish. We have a unusual case in China salmon fingerling in December 2009. Few months ago, we have 2 groups of China salmon here. The first group around 80 to 100 grams of fish, and the second group around 40 to 50 grams of fish. Fish move H5 from state and federal hatchery to UC Davis for conservation research project. And you can see the photo of the tank at our facility. And group 1, we have around 51 fish, and group 2, 93 fish. The fish culture in an outdoor, low freshwater, low tank, with the temperature around 18 degrees Celsius. And the group 1, they're around 2 years old, with the average weight around 100 grams per fish. And we see the mortality around 21.6% occur during 7 weeks periods in December 2019. And you can see the fish have like the skin lesion, and also they have some lesion in their mouth. They have some red lesion in their mouth as well. In this group, you can see the ulcerative skin lesion, like the round red in their body. And in this group, we see around 70% of the fish in the population presented a multifocal ulcerative skin lesion like this. But in other group, we call it group 2, it's 1 year old, around 45.6 grams. We didn't see any clinical sign of disease or gross pathological lesion or mortality, but the fish found positive to mycobacteriosis during experimental examination. So the methods, we collect fish, around 15 fish in group 1 and 38 fish in group 2. We collect supportorial kidney and subsample and inoculate on the blood area, modified hair margin, and modified seal media, incubated at 25 degrees Celsius for 2 weeks. We also collect eyes, brain, gill, heart, liver, spleen, and kidney feces and submit for histological analysis. When we get the poor colony from the bottle kidney on the blood agar, we did the DNA extraction and we run the 16S RNA, and also we run 3 housekeeping gene, RPOP, ITS1, and histone protein to amplify and sequence for 18 bacterial isolate. We also did red PCR using GT5 primer, and the protocol was modified from the author, the paper of the author. We modify the method to run for red PCR. The result around 6 days post incubation, the portal kidney on last area, we see the poor white smooth curved colony with the size around 0.2 to 0.4 millimeter in diameter, and this colony observed around 6 days. And we saw in group 1 around 53% fish infection, and in group 2 we see around 21.1% of the fish have this kind of bacteria. And also some fish have positive role in the modified Thayer-Martin agar. These are the medium selected media for isolation of Fanciella orientalis in fish. Is commercially available and could be benefit as Fanciella orientalis, and it is different for mycobacteriosis, and you can see two plate of kind of colony growing modified Thayer-Martin agar. On the photo on the left is the Mycobacterium calonae. You can see this colony around 10 days after 10 days of incubation. In the right one is the colony of Fanciella orientalis, and you can see the different. You can distinguish between them in the modified Thayer-Martin area. With the histopathology, we have found a little bit finding in the histopathology, and we see that this session demonstrate the histomorphology change only in in the group of Chinese salmon infected with Mycobacterium somnifilum, and we can see in the muscle the cyst of granulomatous inflammation, locally intensely efficacy in the dermis, and underlying skeletal muscle. We see it from the fish have the skin lesion like this that I mentioned in the previous slide. And histopathology we can show in the heart with some small array of mononuclear cells within the myocardium subaqueous of the ventricle. But we didn't find any classic lesion like that in the fish infected with Mycobacterium. So maybe we can have a different infection from this group with the normal fighting with other Mycobacterium infection. The result from the sequence and phylogenetics analysis, and this one we have this after we have some reference gene we download from the gene bank from 3 different plague of Mycobacterium, and you can see have 3 plague here in abscesses, canonae clay, Mycobacterium fortunatum, and in tuberculosis, similar clay that Mycobacterium marinum there is the more very normal species infected, Mycobacterium species infected in fish. And you can see in this phylogenetic tree in Chinese salmon, mostly in two group of the two species of Mycobacteria. You can see this group belong to Mycobacterium salmonifilum, and another group is Mycobacterium chelonae. But interestingly, that's the fish in group 1 that we call it 2 years old. We number that is 2018. Is infection with both Mycobacterium salmonifilum and chelonae here. So this group have both infection, but in the group 1 years old, we only found Mycobacterium chelonae infected to this group. This sequence, this phylogenetic tree we have from the result we concatenation of the three genes RPOP, ITH1, and SP65. The red PCR, we you have the red PCR, and we found out the similarity matrix were generated from the red PCR and using the RT35 rammer. You can see the cell here is the one well is one sample that we run, and you can see the first 7 sample. The pen looks similar, and it belongs to the group of Mycobacterium salmonifilum. And the second group, you see the sample number 3, number 23 and 24. The pen looks similar, and it belongs to the small group here, but the interesting another 6 sample. We have the group fungi, and all of them belong to Mycobacterium chelonae. As a result, phenotyping from red PCR compared to the housekeeping gene concatenation, and we saw that from red PCR, this group is belong to Mycobacterium salmonifilum, and another group belong to Mycobacterium chelonae. Is in the China salmon. We also include 2 samples from koi fish. We also found Mycobacterium chelonae there, and 1 sample delta mass will have Mycobacterium infection salmonifilum. We also include 2 other isolate from betta fish and worktail. Were identified Mycobacterium fortunatum in the phylogenetic tree for comparison. Conclusion: partial sequence of citinet RNA initial identified the recovered bacteria as a member of the genus Mycobacterium. Amplification and sequence of RPOP, SSP65, ITH1 gene identify Mycobacterium salmonifilum as and Mycobacterium chelonae, 2 different members of abscessus chelonae clade. Red PCR and MLST genotyping supports genetic relationship between the Mycobacterium salmonifilum and Mycobacterium chelonae. Mycobacterium salmonifilum and Mycobacterium chelonae co-infection in Chinese salmon group 1, group 2018. Only Chinese salmon infected with Mycobacterium salmonifilum presented ulcerative skin lesion and granulomatosis inflammation. maybe suggest that the environment or the species susceptibility diversity. I would like to acknowledge my supervisor, Dr. Esteban Soto and Dr. David Bridge, and the collaborator from the Mississippi State University, University of West Indies, and UC Davis. I'd like to thank you, our Teach Animal Health Laboratory at UC Davis, for support me and of finding from this research. And thank you for your listening.
Thank you very much, too. Interesting talk. If there's any questions, go ahead and unmute yourself, introduce yourself, and then.
I got a question. Hi, I'm Bart from Michigan State University. I would like to ask you if you see any differential pathology between Chinook infected with only one species and those infected with the two species, because you said basically that one species is almost not producing granuloma, or no?
So you mean the difference between the outside of the fish, or
the pathology grade and the progression, like how fast the fish were developing the granuloma when they are infected with just one species of a mycobacterium or with both?
With this fish, we in the group 1 around 2 years old fish, and we saw some infection from a skin lesion. It happened around 7 weeks of the 7 weeks. We see the mortality during 7 weeks, and some die, and after that they have the skin lesion like that. But in the another group, it's like it looks normal. In the group where we call as 2019, 1 year old, the outside look very normal, and the fish still, I think.
So from the second group, you only get the detection, but no pathology?
No. Like we also do some histopathology, but didn't see any sign of the mycobacterium in the histopathology from the second group. Only found in the group with the fish with the skin lesion.
Mm-hmm. Okay. Thank you.
I've got a question, if I can jump in. This is Jan from New Jersey. Thu, thanks for the great presentation. Nice job on that. I was just curious, incubation temperature can be an indicator of zoonotic potential, and like Marinum incubates at 37 degrees. I was wondering if you checked incubation temperature of this mycobacterium to see if it can incubate at 37 degrees, or if it being from a salmonid, if it's more of a cold incubation.
The mycobacterium is like we know that in this optimum temperature for growing, and this mycobacterium is normally happen in the cold water for the disease in the cold water. So, and the optimum is not I didn't try incubate 37, but it's too high for the temperature. We incubate is around optimum around 25 degrees Celsius, and it's that around after 6 days, around 6 days, we can see the colony is very good. It's not slow roll compared to other bacteria like Aeromonas. You can see after 24 hours. This one we need the not very high temperature, and we need to take around 1 week to see the colony there. Yeah, like answer your question? Or?
Yep, that's great. And one other question that I had, I noticed those external skin lesions that extended into the skeletal muscle as well. I was wondering, I saw you took kidney cultures. Was there any attempt to take any skin cultures from those areas and maybe rule out like columnaris or cold water infection with Flavobacterium?
We also tried in modified growth on modified Sierra. It's the selective medium for Lactobacterium. But we didn't see any kind of Lactobacterium, and so the temperature 25 degrees as we incubate in the blood area is, as we know that the blood area is for all kind of bacteria that can grow on the blood area. But with the Mycobacterium infection in fish, it's trend that we see it nearly really only one species of bacteria is very low growth. So yeah, I'm sure that we don't have another kind of bacteria because we can see it. It's also we can see it on the blood area. We also did in modified seal area selected for Lactobacterium. We didn't see any kind of bacteria like that. Do I answer your question? Oh,
Yep, that's great. Thanks very much.
thank you.
Yeah, just to follow on that, Jan, to clarify a little bit, the only indication of a co-infection other than the Mycobacterium in the group 1, we did saw some fungal colonies in one fish with the skin lesion, but nothing else really grew in any of the other media. So it was pretty pure for a Mycobacterium in the skin. You know, there was some growth of other stuff, you know, in the blood agar, but nothing in the share media. And you know, that's why like the selective media, you know, was used, you know, to try to see if columnaris, you know, or others will grow. But you know, we did sample in some of them the skin as well as the kidney, but only Mycobacterium really grew consistently in any of them.
Okay, great. Thanks.
I have a question for you. This is Gail Kirath out in Seattle. My question also has to do with, it's following on temperature, but a little bit different maybe, in that I think you said that the temperature of the water for the fish was 18 degrees. And so my question was whether any of this kind of pathology or infection was observed in the hatcheries that these fish came from. Do they ever see this? And if not, is it colder water there? What role do you think water temperature might have in the outbreak that you saw at Davis?
Okay. And with the, I know salmon is suitable as cold temperature. And we see that within the temperature is not a problem for that issue. With the isolates, we also include 2 other isolates in the same our facility in koi. We also found Mycobacterium in koi fish there, and also we have dense smell. We also found a Mycobacterium infection in the dental males there in our facility. It's different, not in the same slide, but different tank and different people keep this fish. But we saw some infection there, so it may happen from maybe translate from the water or something. I'm not really sure, but.
Mm-hmm. Has it been seen in the hatcheries that these fish came from?
This fish we kept it around 1 or 2 years ago already in our facility, so it's long time ago. Then the fish, the rook 2 years old, we still keep them on the fresh water. Now at this time they need to move back to sea water, so maybe it's like a little bit stress for them. when they need to change and to move. So we still keep them in the fresh water. So maybe that's maybe the problem for them to have the disease. Yeah.
Okay, thanks.
Thank you.
Thanks again too, and Adrian for your presentations today. We're at 1 o'clock here in Minnesota, so we'll wrap up the seminar and